look at number 2 and see if this is what you have. Once you figure out what your tick marks are, one thing I like to do is I like to find the period, and the period's 2 pi. And then once I get to this number, I split it in half. And 2 pi is not too hard to split in half. 1 pi. And then when I get to this tick mark, I split it, both of these in half. And then you just think, what is half of 1 pi? And we're going to have different numbers here that we're going to do this with. And that is 1/2 pi. And then once you get this first tick mark, you can kind of start counting by 1/2 pi. Because you'll have 1/2 pi, 2/2 pi, 3/2 pi, 4/2 pi, 5/2 pi, 6/2 pi, 7/2 pi, and 8/2 pi. But, you know, obviously 8/2 you reduce to 4. And then sign always starts at 0 if it's not shifted right or left. So the nice thing to remember about sign is starts at here, every other tick mark it's hitting 0. And then if it's positive, so this one is a positive 1, so it would go up to +1. And down between these two, up between those two, and down between those two. So make sure your graph looks like that. That graph can be, you know, I guess make that be 3 points. So if you just missed a little bit of it, like maybe you got the labeling off, you can take off a 1/2 point if you just missed a little bit of the labeling. Okay, just for your notes, what is the amplitude again on this? Okay, on this one it's 1, and what is it on the graph? Like, what does it mean to be the amplitude of this?
It's from the middle line to the highest.
Okay, from the middle, how far up and down does it go? So it goes up 1 and down 1, but it's always positive no matter what. Okay. What is the period of this? What does the period mean? It's the shortest part before it starts to repeat. So it starts here. When does it start repeating? No, not yet. At 2 pi. So the regular sign has a period of 2 pi. And the domain, how far right and left does sign go? How far to the right? Infinity. How far to the left? Can I take the sign of negative angles, like the sign of -pi/2? Yeah. So it goes all the way right and left, so the domain is all real numbers. And the range is the y values. How far up and down does this one go? Lowest is -1, highest is 1. Okay, so for cosine, if you think of the unit circle, cosine is the x-coordinate. So at 0 degrees, what is the x-coordinate at 0 degrees? 1, right? So that's why the cosine starts at 1. And the cosine's a little bit, for me, it's a little bit harder to draw for some reason, or it seems to be for most people, just because sine, it's easier to just draw the top hump and the bottom hump. So here is 1. And the next thing, this is where everyone always messes up. Do you see how it looks similar, but it just starts somewhere different? But this is the part that always gets messed up, is once you find the top, make sure the first tick mark, you hit the first tick mark. Because oftentimes, I have students come from here and they go clear down to here, and they miss the first tick mark. So the first tick mark is at 0, because right here, the x-coordinate is 0 at pi/2. So don't forget to hit that first tick mark. And just like the sign, every other tick mark is hitting. So sometimes I like to do that. Once I find that first time it crosses the x-axis, just start going every other tick mark. So it goes up 0, down 0, up 0, down 0, up. So one cycle of it is the part before it starts to repeat. So you start right here, And what point does it start to repeat? Here again. So that's just one period of the cosine looks like that. Although if you look at it, you know, from like here over, it looks just like the sine, just from that part. It's just shifted of the sine. Domain is going to be the same thing. All real numbers. The period on cosine is the same as pi, just your regular cosine. Amplitude, same thing, up and down from 1. And the range, same thing on your basic ones, -1 to 1. Okay? Do you guys think you know what this graph would look like? What would 2 sine of x look like? What does a 2 out front of the sine do? Okay, bigger amplitude. Yep, and this number right here, that's right in front of it, it will always determine the amplitude. Every single time. That'll tell you how far up and down it's going to go. Because it stretches the y values by 2. So on this one, the amplitude is going to be 2. And it's the distance from the middle to the top, or the distance from the middle to the bottom. So it's always positive, even if I put a -2 up there. So let's actually make this one be a -2. So even though it's a -2, the amplitude is still 2. Okay? The period, I haven't done anything to make it go in and out different with the period. I can't think of the word. I always get confused. Horizontally, I'm not doing anything horizontally to it. I always get confused between horizontally and vertically. So this one happens to have, the period is the same. And it's all based on this right here, the x values. So the period on this is still 2 pi. Okay? So if the period's 2 pi, you've just got to go 1, 2, 3, 4. Your fourth tick mark will be 2 pi. So that's always kind of how you start. Always go to your period, find that, and then you've got to figure out how to label all 8 of them. Of course, this one we've already done, but you know, you can go 1 pi is easy to label. Kind of label what's easy. 3 pi, 4 pi, those are easy. And then you can either think to yourself, take this one and split it in half. Or, if it's easy to see, you can always say the one between them is just the average of the 2. So this tick mark would be 1 pi plus 2 pi is 3 pi divided by 2. Just add them and divide by 2. So this would be 3 pi over 2. Add these and divide by 2. 5 pi over 2. 7 pi over 2. That's always one way you can get the tick marks. Or just go 1 half, 2 half, 3 half, 4 half, 5 half, 6, 7, 8 halves. Okay, whatever is going to make it easy for you. This one is not shifted. So where does the sign start if it's not shifted up or down or right or left? Always starts at 0. So you guys are going to put your tick mark there. And I know some of you will just want to draw it from there. But I suggest, just to keep it straight so you know you're not going to start doing your wave and get it in the wrong place, I suggest once you have the 0 there, just remember that it's every other one, and that's where it's going to be. I would do those before I went up and down. Okay? And then from here you got to decide, am I going up first or down first? Okay, this one I changed it to a negative. So this one, since it's negative, will go down first.
You're going to go down all the way to the -2.
Yeah, and this one, since amplitude's that, I'm going to go down to -2. So I probably should label my axes just so I can see. And really, they almost all look the same. It's just a matter of how you label it. But it's almost the exact same graph as you guys just graphed on your quiz. So see if you can fill that in. Got your notes out. Get it in the right spot. And just fill it in. Make sure you go down first. In between these two. Up between these two. Down and up. And when you connect them, make sure you do it in a smooth curve, and this is going to be like a parabola shape. Concave up, and then this one will be concave down. Don't make them too jagged. Don't make them like that's a little bit too jagged. Don't make them like a triangle, sharp. They've got to be curved. And then put your arrows on the end. This one had stuff change a little bit. Domain, what are the x values on this that it goes through? That was the range. But domain on all of these, sine and cosine, all real numbers. But range, yep, this one switched. It goes between -2 and 2 this time. So as I go to graph this one, we can talk about what they're going to be, but do you guys think if I just said graph y equals cosine of x that you could graph it? Like where does the cosine start? And this is a positive one, so it would start up, right? So the regular cosine would start right here. And then key thing right here, hit this first one. You got to make sure you hit right there, because if you don't, you're going to mess up the whole rest of the graph. So it starts up and then it hits. And again, I know some of you just want to start drawing, but if you just make sure you hit every other one, then you're going to be safe. So it should hit on the first tick mark every time, if it's not shifted right or left. And then do you guys think you could drop cosine from there? What is it doing between these two tick marks? Down. And between these two, up. Down and up. Right? Well, if I change my labeling, I've graphed this graph. I just got to figure out what it's doing. Because what is the amplitude on this one right here? 3. So all I have to do to change that is make sure I go 1, 2, 3. Now it's going to be at 3. So as long as I label it that I went up and down to 3, and I'm fine there. Okay, this number right here is going to change the period. If I were to plug something in, let's say I kind of decided I wanted to make a table of values. Normally, I plug in 0, I would get cosine of 0 is 1 times 3 would be 3. But this is going through the x values twice as fast. Because if I want to plug in, normally we would plug in pi over 2 next. But when I plug in pi over 2, then it turns to pi, right? So it's going through it faster. I need to plug, it would have to be like if I plugged in pi over 4. If I plug in pi over 4 right here, then I would get pi over 2. So the x values are going twice as fast. So the period is actually going to be half as long. Because it goes twice as fast. So by the time I get to 2 pi, this is going twice as fast. It's going to do 2 cycles by the time it gets to 2 pi. This is how much faster it's going. So the easiest way I have found to do it is whatever, you take your normal period, 2 pi, and whatever this value is right here, you divide by that number because you're chopping the period in half because it's going twice as fast. So whatever this number is, if you divide by it, that will tell you what your period is. Because it goes twice as fast, so the period's 1 pi instead of 2 pi. So the graph is what it does is that when you go to your 4th tick mark, 1, 2, 3, 4, instead of this being 2 pi, this is now 1 pi. And now you've got to figure out the rest of it. So it just went twice as fast, and this is how you figure out what it is. So now, if I'm here, I like to just start breaking things in half. What is this tick mark right here is half of this tick mark. What is half of 1 pi?
Pi over 2.
Pi over 2. And then this tick mark is half of this tick mark.
So it's pi over 4.
Pi over 4. Now this one, you guys can kind of think half of a half is a fourth, right? But if you get something weird, let's say that it was 5 pi over 6, and you wanted to find out what half of 5 pi over 6 is, all you have to do is times it by a half, and it would be 5 pi over 12. So if you ever want to know what half of something is, just times it by half, and that's what it is. So now we've got to figure out the rest of the tick marks. There was 1 pi, there was 2 pi. What do you guys suggest? I like to just count. This is 1/4, this is 2/4, this is 3/4. Alright? This would be 4/4. Just reduce it as you go. This one would just be 5 pi over 4. 6 pi over 4. 7 pi over 4. And 8 pi over 4. 8 pi over 4? 2 pi? And it's the exact same graph, but you just had to relabel it. And now you have your graph. Yeah.
And you always have to have that one tick mark in between the points on the x-axis, right? Like, you couldn't just have it be, like, you have to have the...
So this one always lands on the first tick mark, is that what you're
No,
saying?
I get that, but like, so in our other
Oh,
graph,
yeah.
so we went by force in this one, but we have to go by force because there has to be the tick mark in the middle of the two, right? Like, there
Yeah.
has to be that tick mark for
Yep.
the answer to be right.
Yep.
Okay.
This one, remember, this is kind of the rule if you want to write it down. If you have an a sine bx plus c, and then so, I guess you could have something added out front. So you could have a number in front of the function, you could have something in front of the x, you could have something added on in there, and something added out front. And that could be with sine or cosine. The amplitude is always going to be what on these? A. Or we should probably say the absolute value of A in case it's negative. So that's always the amplitude. The period is always going to be on sine and cosine. The regular one would be 2 pi, but if I have a number in front of the x,
It's 2 pi divided by b.
2 pi divided by b. Or, no, this just shifts it right and left. Or I guess if it's a fraction, you might want to do 2 pi times 1 over b. Or the reciprocal of b. Right? I mean, that looks similar. And the c and the d are going to shift it up and down. So, I mean, we'll talk about what the c does. But vertical shift, so up and down, the vertical shift is just going to be whatever's added on. So the vertical shift is just plain d. So if it's a -2, it's going to go down 2. If it's a +2, it's going to go up 2. Or whatever it is. So the a stretches it up and down, but that just shifts the whole thing, shifts the whole thing up. And we'll have to do some of those. Okay, so this one, what is the amplitude on this one up here?
8.
8. Absolute value of 8, which is just 8. Period is 2 pi
Times
divided by 1/2, right?
So it's equals
Or
4.
2 pi times the reciprocal. Yep, 4 pi. So this one, the period would be 4 pi. So can you kind of imagine what it looks like? It's going half as fast. So by the time you get to the regular 2 pi, you've only graphed half of the cycle, half of a period. Okay. So the 5 is doing nothing to the period, right? It's just shifting it up 5.
Yeah.
What is going to be the amplitude of this one?
3.
Absolute value of -3, +3. Yep. Period is going to be
6
divided by 1/3, or yeah, or 2 pi times, so think of this as 1/3. Whoops, times 3 is 6 pi. You guys want to graph this one? It's going to shift up 5.
Yeah, I kind of want to see how you shift it.
Yeah, we need to shift one up, right, before it's easier than shifting it left and right. Okay, if I'm going to shift it up 5, I like to go 1, 2, 3, 4, 5, and then instead of having my x-axis, I like to just draw a dashed line so I can kind of keep track of where I'm at. Okay, so normally the sign has a bunch of dots on the x-axis. Well, this one's going to have a bunch of dots on this dashed line. And then from here, I've got to figure out, since the amplitude's 3, what do I need to do for the y values on this? Okay, we'll go up 3 from this line and down 3 from this line. So it's going to be, the graph should be between these points right here. So I'm basically going to graph it the same, except for I'm going to graph it on this dashed line, and I'm going to change the tick marks on the x-axis so that it has a period of 6 pi. Yeah.
Wouldn't it go down?
Oh yeah, I didn't go down far enough today. Yep. So it's going anywhere from 2, here's 5, and then here's 8. So the range on this one's going to be between 2 and 8. Questions on this part? So all I've done is I've just got it ready to shift up 5. I'm still going to go 1, 2, 3, 4, right 6 pi. 1, 2, 3, 4, what's that one going to be? 12 pi, because that's my period, 6 pi. But I want you to be able to label the rest of them. So what are some easy things to label right now?
The halfway.
3 pi. I might as well go label all those, right?
Yeah.
There's 3, 6, 9, 12.
Then you would do half of 3, which is going to be...
Yeah, half's going to be kind of easy on this one.
3 pi over
3 pi over 2 is halfway between these two going to be easy. Add them and divide by 2.
2. So 9 pi over 2.
9 over 2. Half of this will be easy. Add them, divide by 2.
13 pi. 15 pi
15
over
over
2. Oh
2.
my gosh.
Add these two, divide by 2.
There's only 1 pi over 2.
And this would have been kind of harder to count by, but this is going every 1.5. This would be 1.5 pi, 3, 4.5, 6. And probably if you put that, I wouldn't care, since it's a terminating decimal. You put 1.5 pi, 3, 4.5 pi, 6, 9.5. No, not 6. 7.5 pi. Okay, so now we've got to decide where we're putting our dots. It's signed, so does sign start on the line or above or below it?
I mean, on the line.
On. So I'm right here, I'm starting on the line. So I'm starting here. I'm just going to go every other tick mark and get it on the line. So here's this one. That's on that line. Just remember every other tick mark's on the line, and then you'll be set. There's every other one on that line. And now I got to decide, do I go up first or do I go down
You
first?
go down first, but it's negative.
Okay, negative, so I'm going to go down, and I go down 3. So on this tick mark, I go down 3. This tick mark, I go up 3. Down 3, up 3, and I'm done. Just need to connect them.
So wait, would the domain still be all real numbers?
Yep, on all sine and cosine, it's always all real numbers.
Just making sure.
So now I just connect it with a smooth curve.
I'm going to have to remember these negative numbers.
And that's what I'm going to be looking for. I mean, I will be looking that you have the right top and bottoms. I'll be looking for all those points. I'll be looking for all of this on your test. Pretty much everyone's graph should look like this. I'm not looking for anything less than that. Yeah.
So would there be a negative side?
We've got to shift. Do you guys remember compared to this graph right here? where this one shifts, but has a 4 there. But they're kind of weird when they have that there, because it doesn't just shift left one. One way you can do it is you can just say, okay, how can I get this just to be normal? Like, how do I undo all of that? If you just set whatever this is equal to 0, it'll show you where it shifts. Because if I subtract 1, divide by 4, this one actually shifts left 1/4.
Negative 1/4.
Negative, well, yeah, well, left 1/4 or
And divided by 1.
negative 1/4, whatever.
I'm tired.
Okay, so this is going to do the same sort of thing with these. I'm going to do kind of a crazy one, not just a plain shift. I'm going to change the period and shift it. Okay, what all is this going to do? What is this 3 going to do to it?
It's going to shift it.
Shift it. Because it's added onto the end, right? And it is a positive 3.
Oh, yeah.
So it's going to go
Up 3.
and then it's a negative 1, so
This is a 1 here, so what does the negative do to
it's
it?
going to switch it. So it's going to flip it.
It's going to reflect it, I guess, over the x-axis, right?
Yeah.
What does that 2 do to it, just by itself? It makes the period be
Pi.
2 pi divided by 2, so pi, yes? And then, what does this do to it? So those 2 together are what shifts it right and left.
So it's going to become positive pi over 2, so you can move over pi over 2.
Remember, you can always just set it equal to 0, so it goes right pi over 2. That's where it's going to start. That's the kind of the crazy part is it doesn't just shift it pi. Everyone always forgets that it shifts it this divided by this. Because the 2 not only affects the way that it goes left, the horizontal shrink and stretch, but it affects the shifting. So now we got to be able to graph all of that. Whoops, maybe go up a lot bigger than that. Okay, what do you think would be the first step to start?
First, I'll graph where
It'll shift it.
Shift it up? You want to do up
left or
first?
right.
Yeah.
Okay, we're shifting it up first. What am I doing to shift it up? 1, 2, 3. So normally this is going to be like my pretend x-axis on my new graph. How far up and down is it going from this line? Amplitude. 1. So it's just going up 1 from it and down 1 from it. Okay. Period. I'm just going to start, and I tried to do all the ones that you guys have. I tried to make them shift so that they landed on a tick mark, and on the test they do too. It's kind of hard if the tick marks are counting by like halves, but it shifts a third, and that's super hard. But most of them are going to be, and I won't touch on any that do that crazy. So you're still going to just go, I would start with just your period without thinking of the right and left shift yet. I would just go 1, 2, 3, 4. That's your period, which is, we decided our period was pi. So I'm just going to go to there for right now, and I'll worry about this shift in a second. And then I'm going to go 1, 2, 3, 4, 2 pi. But it is shifting, and I really do try to make sure, to make it a little bit easier, that it shifts onto a tick mark. So it's going to shift right pi over 2. Where is pi over 2? Here's pi.
Like right in the middle.
in the middle.
So it's shifting right here. So I don't know if you, because when we get to graphing secant and cosecants, we have a lot of vertical lines that we draw, but for today, this is fine to say, okay, this is like my new y-axis, right? So I'm really just graphing cosine as if this is my new x-axis right here, and this is my new y-axis right here. But it gets kind of messy when we do it with secant and cosecant because we have so many lines going up and down.
So does that make it a new, like, pi, like a new distance from that y-axis, or would we automatically graph it where pi is?
I don't know.
Okay, so you know the period is pi, so like, because the y-axis is moved over to pi over 2, would we graph it where pi originally is, or would we graph it still?
So it will still go pi away from where it starts. So it will go to right here.
Okay, just making sure.
That one cycle should still be the same length.
Okay.
Can you guys see what this one is right here? And we could do it a couple ways. Right here, this point is in the middle of these two. So you could add those and divide by 2. One way to do it. Or every other one is a half a pi. Here's 1 half pi, 1 pi, 3 half pi, 2 pi. This one's going to have to go a little bit farther. Since I moved over 2 tick marks, I'm going to have to end over 2 tick marks also. Do you think, what is this tick mark? If this is a half, what is this one? 4. Okay, so you guys all should be graphing this. I want you to fill in the bottom tick marks. So we haven't started graphing it yet. So when it reflects over the x-axis, this is our new x-axis, we're just reflecting over this. So, no, it's going to be up here. Yeah, that's kind of confusing, but it's just reflecting over this part. Over this, our pretend x-axis. So, we kind of, because really technically we would probably flip it and then shift it up, but we're just going to shift it up and drop from there. But it would flip here and then shift up, and so it's going to be up here. When you go to graph it, normally, pretend like this is 0, 0 right here. Normally, where does cosine start if this is 0, 0? Does cosine start on 0, 0?
No, it starts above.
No, it starts
negative,
above.
but since it's a negative, so we have to start at -1.
Yep, but it's a negative, so this one's starting below. So it's starting here. Yep. And now, don't forget this first tick mark. It's the hardest one on this line. So it's right here. And I would seriously stop right there and then hit the line every other tick mark just so that you can get it right. Like when I do it, I really do. I go here and then I just start going every other tick mark so that I make sure I get those in the right place. And then once I have those, then I just go above and below, do the dots, connect it. I mean, I know some of you want to just be fast and start drawing it, but sometimes it just messes you up and it's faster to just not mess up and have to go back. Or just to get it right, right? So once you figure out it's down here, just go every other tick mark, put it where it's supposed to be. This one, up, between these two down, up, and down. And then make sure you don't make your graph like this because this is the lowest point, so it's got a curve and come up right here. And make it a round, smooth, round curve. And really, everyone's graph should look the same. You should have the same amount of points graphed. You should have the same amount of tick marks graphed. And if you don't want to do the dashed lines, that's fine. But you should have them in those spots. If I give you a graph and I just ask you what is the period, just make sure you're looking for the shortest repeated cycle. So if this one is kind of starting here and then it went up, you just got to look for something. Either if you can figure out what this top mark is to this top mark, that's one period, right? Or if you need to, you can go from this one to this one and figure out that the length of that is one period. So you'll have to look at the x-axis and try to figure it out. For some of them you just got to look. You have a couple story problems where it says, here's the cycles of the moon and this is how much of the moon showed. And it asks you what is the period of the moon? What's the length of it? So you got to kind of just be thinking, where does it start repeating and find the length of it. So just the length of it, whatever they happen to be. I mean, if I put numbers here, you would just subtract them, find out the distance between them. but just kind of look for that where it starts to repeat. That's one period. If I have this question right here, what is the amplitude of this graph right here? Absolute value negative 2, 2. Period. Period is going to be 2 pi divided by what number?
3 pi over 6 over 3 multiplied by 2 pi over 3, 4 pi over 3.
Okay, so 2 pi multiplied by the reciprocal. So either divide by it, but if it's a fraction, just remember multiply by the reciprocal. 2 over 3 pi. What happens if I have a pi in there?
Pi's cancel out, so it's going to be 4 over 3.
4 over 3 would be that period. So, I mean, that would be kind of ugly to graph, but it wouldn't be that bad. It's more a matter of the fractions are kind of a pain. You'd go 1, 2, 3, 4. This would be 4/3. Well, 1, 2, 3, 4, what would that be? 8/3. Now just remember, this is half of this. What's half of 4/3?
2/3.
2/3.
And then
Well, what's
1/3 and 3/3.
1/3.
And
so
one.
everyone is 1/3. And you just count it out. So just don't forget, half that to get to here, half that to get to here.
And then the other one's going to be 1.
And then this has to be in the middle of them. You have that one have to be 1. So it seems like they're bad, but if you can divide fractions in half, then you'll be
Yeah.
fine.